Hello students, my name is Udit Mittal. I'm assistant professor in JSS Academy of Technical Education, Noida. Your theory course, Power System Analysis, in this PSA subject, Unit 3 is about load flow studies. And in load flow studies, the first topic is the formation of Y-bus matrix. How to construct, how to form bus impedance matrix. So when going for load flow studies, we basically adopt a Y bus matrix, and Z bus matrix is used for fault analysis, whereas Y bus matrix is used for the load flow studies and stability analysis. So this is the very important point to consider, that bus impedance matrix is particularly useful for fault analysis, and bus admittance matrix is useful for load flow studies and stability analysis. Now let's consider a three bus system in which three generators are there and three transmission lines are there. So let's consider this system. Now in this system we have to represent the given system by the admittance diagram, or we can say the impedance diagram. So that impedance diagram is basically we have to move one step forward, and then we have to represent it in admittance diagram. So we have to try to write every value in its admittance form and not in impedance form. So we have to represent the whole system by its admittance diagram. So for that, what we do, the generator with EMF E and series impedance, suppose ZS, is represented by a constant current source and admittance in parallel. So for every generator we do the same. We represent the EMF by a constant current source. Actually we are doing the source conversion here to convert the system into a impedance admittance forms. So for that, generator EMF E and series reactance X can be converted into a constant current source I in parallel with the admittance Y, where Y is equal to 1 by X. Transmission line is represented by nominal pi method. So transmission line is represented by nominal pi method. This nominal pi representation is basically preferred for admittance calculations. Now this is the representation of the system given three bus system. Let the bus voltages be voltage of bus 1 be V1, bus 2 be V2, and bus 3 voltage is V3 respectively. Now the impedance of line between 1 and 2, so you can see the impedance here, the impedance is Z12 and the corresponding admittance is Y12. Likewise impedance Z13 here, Z23 here, and the corresponding admittances you can see Y12, Y13, Y23. And as we have to show the transmission line, we have to represent the transmission line by its nominal pi model. So we have to show the shunt admittances also. So if Y20 is the shunt admittance for line 1 and 2, so Y120 by 2 and Y120 by 2, these two on either side of Y12 are the shunt and half of the shunt admittance of the line between 1 and 2. Likewise this Y130 by 2, Y130 by 2, these are the half of the shunt admittance of the line between 1 and 3, and similarly Y230 by 2, Y230 by 2, these are the half of the shunt admittances between the line between the line 2 and 3. So Y120 by 2 is half of the shunt admittance of the transmission line, one having series impedance Z12. Now apply nodal analysis technique at node 1, that is bus 1. So I1 is basically equal to Y1 V1 plus Y1 V1 Y120 by 2 plus V1 Y130 by 2 plus V1 minus V2 Y12. So this is V1 minus V2 Y12, this current through this element, and V1 minus V3 Y13. So V1 minus V3 Y13 is current through this element. So if we solve this further, we are getting equation number 1. So V1 Y10 plus Y12 plus Y13 minus V2 Y12 minus V3 Y13. So we are getting equation 1 here. Similarly, we are getting equation 2 and equation 3. So by symmetry, we can also get the equations 2 and 3. And then we represent the three equations 1, 2 and 3 in matrix form. So this current vector I1, I2, I3 is equal to, so this particular matrix is basically admittance matrix, and this is voltage vector. So if you notice here, there are diagonal elements, and there is a upper triangle and there is a lower triangle. So this is lower, this is upper, and these are the diagonal elements. So you can see here that the diagonal elements for suppose bus number 1, the element value is for this bus number 1, the element value is this, that is Y10 plus Y12 plus Y13. So that means all the admittances connected to bus number 1. You can see here that all the admittances connected to bus number 1, Y1, this is Y12, this is Y13. So these are all the admittances that are connected to bus number 1. So, and what is Y10? Y10 is basically Y120 by 2 plus Y130 by 2 plus Y1. This is Y10. So Y10 and this is Y13 and this is Y12. So this is Y10 plus Y12 plus Y13. Fine. So this is how the diagonal elements you can see we are getting, and the off diagonal elements, upper triangle, lower triangle is there. You can see the symmetry is there in the elements. So as we have considered the 3 bus system, the Y bus matrix, the admittance matrix is a 3 by 3 matrix. That means the order is 3. So in general, we can write like this. I1, I2, I3 is equal to Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33, and then a voltage vector. So this is called the bus admittance matrix. Now what are the properties of this matrix? There are certain properties. You can observe from here that Y bus matrix is a symmetric matrix. Upper triangular matrix is equal to lower triangular matrix. So you can see that upper triangular and lower triangular matrix, there is a symmetry here. What is the second property? Each diagonal element for a particular bus is the summation of admittances connected to that bus. So that means each diagonal element, if you see here, for suppose this diagonal element, if you see this element, you see, so this is pertaining to bus number 3. So all the elements, this is what Y30 plus Y31 plus Y32, So if you see here, y30 plus y, if you see here for bus number 3, y23, y13, and the summation of y230 by 2, y130 by 2, and y3, this y3 is basically y30. So we are getting the self, the diagonal element, or the self, you can say the admittance for a particular bus is nothing but all the admittances getting connected to that bus, and that forms the diagonal element. So this is the property, and if you see the third property of diagonal elements are negative of admittances between two buses. So that means if you see here, this is y12, so this is the admittance between buses 1 and 2, and if you go upwards and see here, so this y12 is minus, corresponds to minus y12. That means the admittance connected between the bus 1 and 2 and the negative of that, so minus y12. Fine. So that is how we can simply write the bus admittance matrix. And what is the fourth property? That addition of any row or column is equal to admittance connected between that bus with respect to ground. So you can observe that if you add this particular column here, so you are left with y1 naught. So y1 naught is the admittance of that bus with respect to ground. So there's a note here that sparsity, what is the sparsity? That how many number of elements are 0 in the y bus matrix. So sparsity is total number of 0 elements upon total number of elements in the y bus. And how to find the total number of elements in the y bus? N square, where n is the number of buses in the system. So now there is a simple problem here, as I have given the notes to you. So you can easily solve this problem and find the sparsity for this particular case. Thank you.